Hello wonderful person, this is Anton, and today we're going to be discussing new discoveries, and somewhat unusual discoveries, in regards to our moon and its effects on planet Earth. And to be more specific, we're going to be talking about what the scientists recently discovered about the internal structure of the moon, how the moon influences the magnetosphere of planet Earth, and a tiny piece of the moon that actually might be one of the quasi-moons we've discussed in one of the previous videos. So let's talk a little bit more about this, starting with the recent discovery coming from inside this beautiful object. So for a few decades, the scientists have been actively trying to figure out what exactly does the moon look like on the inside in terms of its actual structure. For example, when it comes to planet Earth, we know that we have the mantle and several layers inside the core. More importantly, there is a solid core somewhere inside. And all of this was of course established by listening to various earthquakes as different types of waves propagate and reflect inside planet Earth, allowing the scientists to build a three-dimensional image. As a matter of fact, relatively recently, there was another major discovery about planet Earth, potentially discovering an inner core. You can learn more about this in the description. But on Earth we have a lot of different detectors. On the moon, not so much. And the only seismic data we have from the moon is relatively old and not very accurate. It's basically the data collected during the Apollo missions. But in this case, we would require thousands more data points in order to figure out the exact structure of the moon. But the scientists behind the recent paper managed to come up with a somewhat intriguing technique that relied on comparing various models with what we're observing from different external missions. So for example, by looking at certain types of topography and various deposits on the surface, and collecting data from space missions using various lunar laser ranging experiments, they were able to determine the overall deformation on the surface of the moon that's usually caused by gravitational interactions with our own planet. And because these were extremely precise, these tiny observations of deformations from planet Earth and the variations in distance allow them to basically determine the density inside the moon. And by then modeling this and comparing this with observations, they found at least a few models that seem to match almost exactly, discovering several things. First of all, naturally, denser stuff is much deeper inside the moon, with some of these elements even escaping to the surface when the moon experienced major collisions, now actually visible on the surface of the moon in certain regions, but more importantly, almost definitively determining that the moon has a core. A core very similar to planet Earth, with a liquid outside and a solid inside. And the radius of the outer core is approximately 360 kilometers, with the inner core being about 260 kilometers, so actually pretty large, approximately 15% of the size of the moon. With all of this determined because the density here was extremely close to the density of iron and extremely similar to what we find inside planet Earth. Although here this is maybe not as surprising because it sort of does fit some of the initial observations even from the older Apollo missions, even though the data here was not super accurate. Although I guess more importantly, this definitively explains how the moon was able to maintain a powerful magnetosphere in the first billion years or so, something that seems to start to decline about 3.2 billion years ago. As a matter of fact, at some point, the magnetosphere of the moon might have even been more powerful than planet Earth. And so here, the actual explanation would be, well, it's basically the outer core, similar to planet Earth. But eventually the magnetosphere disappeared just because the core is much smaller. And we do expect something like this to happen to planet Earth sometime in the future as well. And so at the moment this is maybe the best explanation for what the scientists are observing, and of course makes a lot of sense. Although I'm sure we're going to have follow-ups in the future. But there were of course other discoveries. And actually discoveries in regards to how the moon influences the magnetosphere of the planet. And it's an extremely similar effect that's responsible for the tides. Basically, the moon pulls on the Earth in such a way that we get these two bulges on two sides, which result in powerful tides across the planet. But turns out a very similar effect happens around planet Earth as well. And specifically, it looks like the moon produces very similar fluctuations in what's known as the Earth's Plasmosphere, an unusual shape around the planet that represents a kind of a plasma ocean right on top of the magnetosphere itself. In other words, it sort of does act kind of like water, almost like a liquid, except that this is ionized gas that seems to act like a liquid and obviously protects the planet. And in the last 40 years, various NASA satellites, such as the ones you see right here, known as Themis, or the Van Allen probes you see here, occasionally transferred from one side of the region to the other, in the process recording what's actually happening inside the plasma. But it wasn't until this paper and some of the recent analysis that someone finally managed to connect the dots. This unusual shape protecting the planet has very similar patterns to what we observe on the ocean of planet Earth when the tides occur. And that of course implies that it's probably from the moon. And might also help us finally explain the unusual variations and unusual observations visible in structures such as the iconic Van Allen belts, the highly energized regions around the planet that do change in time for various reasons, with the lunar tides very likely playing a role as well. But exactly what these effects are is currently unknown. And then we have this last study in regards to the moon that potentially discovers a tiny piece that's missing from the surface. And this is an unusual object we've discussed previously in some of the videos in the description that basically is a kind of a quasi-satellite of planet Earth. It doesn't orbit exactly around the planet and doesn't really get influenced by planet Earth, but it always stays in the same orbit around the Sun and sort of goes around Earth as well. This object was previously known as 2016 HO3, but it now has a more difficult to pronounce name that... Okay, let's do this. Kamawalewa. Okay, leave your complaints in the comments below. And so this object has been studied quite thoroughly for the past 7 years. But what's really unusual about this asteroid, that's only about 100 meters across, is its similarity in terms of surface to our own moon. And more recently, the scientists also discovered that its orbit is also particularly unusual. Now, there are generally quite a lot of intriguing asteroids out there, and some of them are known as Apollo asteroids, the ones that usually cross the orbit of planet Earth. There are also quite a lot of objects that generally share the orbit with various planets. Some of the most famous examples are around Jupiter, and we usually refer to them as Trojans. But these are more commonly known as co-orbitals, and there are 3 different types. We have the Trojans, horseshoe, and retrograde satellites. Here's an example of a horseshoe, essentially an object that sort of does a kind of a touch and go every few years. Whereas the Trojans are usually in the same location, approximately 60 degrees between the planet and the Sun, while the retrograde satellites go in the opposite direction. These are extremely rare. And unlike Jupiter that has like billions of different co-orbitals, at the moment we think our planet only has 21. 2 of these are Trojans, 6 of these are quasi-satellites, and 13 of these have that horseshoe orbit. But this particular object seems to be kind of unique, mostly because, unlike other asteroids that seem to have a very temporary orbit that might actually disappear in the next few years, here we have a somewhat permanent orbit, or at least it stayed in this orbit for possibly a few hundred years. But it's also an orbit that it's going to maintain for over 1,000 years from now, although we don't really know what's going to happen after. And so because of its unusual similarities to the surface of the moon, and because of its unusual orbit, a lot of scientists have been speculating that this is maybe an older piece from our own moon, created sometimes in the past when something slammed here, releasing all of the fragments. And based on various simulations, the scientists were able to work out one thing that nobody could explain before: the unusually high inclination in comparison to our own planet. Here it's about 8 degrees, which would be unusual for a fragment coming from the moon. But by crunching the numbers, the scientists worked out that it very likely started with a much lower inclination, and during its close approaches to planet Earth, this is something that increased over a period of several hundred years, and it's most likely going to change in the future. And more importantly, also discovering that the actual impact doesn't even have to be that powerful. The debris here needs to travel at approximately 6 kilometers per second in order to assume the position. And so any crater that's larger than about 30 kilometers could have been responsible for the production of this particular piece, with these large events potentially happening every few million years. And so this could have been formed any time from today to maybe even several 100 million years ago, meaning that this is possibly an extremely exciting object to potentially explore. Because it's literally a piece of the moon that was ejected from the moon, with potentially some of the most pristine samples of the internal structure. And it just so happens that, well, China started planning a mission here a few years ago. The mission known as Tianwen-2 that's supposed to launch in 2025. And it's not just any mission, it's a sample return mission, which would be super exciting. They're also going to be visiting this unusual comet that's technically an asteroid in order to see what's going on here as well. And so, if everything goes well, maybe in the next 5 years or so, we might have extremely interesting data coming from these 2 objects, which could potentially serve as a really important piece for a lot of scientific studies, technically making the return sample from this object way more intriguing and way more interesting than anything else we've ever recovered. Because not only does this represent the moon, it also technically represents ancient Earth. because the samples here might finally be able to prove this idea. The idea that the Earth and the Moon were created from the same collision. But I guess we're going to have to wait and see until the mission launches and until the samples are recovered. And at least for now, well, that's pretty much it. A few exciting discoveries about the Moon and from the Moon, and there will be more coming in the next few months. Make sure to subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, and maybe support this channel on Patreon by joining channel membership, or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye-bye. Kamo olewawa. Kamole wawa. Kamo ua alewa. Kamo o alewa. Oh wait, it has an asterisk. I think I'm supposed to go Kamo alewa.